Alright, so, starting again with and alright, anyways, moving on. So, it came up in my YouTube feed about a person that was making their own water heater through a rocket stove. And I believe he was Australian, he had the accent. It was a stainless steel project with an insulated pipe that he was using, and it seemed cool. Um, Anyways, I was just thinking about it because it was like, well, I remember my camper van recording I did, and I explained the 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 heat exchanger, all this other stuff that I had for that, but it's like I don't think many people are probably going to make that. But, this is not a terrible little thing to try to change because it's fairly quick to I think turn it like a rocket stove into something a little bit more uh, efficient, maybe, or at least better at utilizing the given physics that it can to be a little better at what it's trying to do. And anyways, I don't know. I just think I could make it better. You know what I mean? Like long and short of it, that's kind of what it's about. So it's like, all right. So if I have this going into a because all it is it's kind of like an L pipe with like an angle to the short end of the L. And it's like we all know about parabolic funnels. You should always seemingly have them in like anything that's any kind of air pump. you know, they're like just immediately add that. You know what I mean? Like at the entrance for the air intake, right? But it's like okay, so instead we're gonna make a different type of funnel, at the where the long part of the vertical stack of a pipe is. Right, so it's like that bend. You kind of want it to be able to bend a little bit better. So instead of having like that little perfectly straight bend or any of that, and at that first corner, all right, that's going to be where the beginning of the funnel is, and then it'll open up around those sides, and then we'll take that and split it, and then have that draw itself in towards the sides of where that initial funnel is. All right, and it's like all I'm trying to do is take the regasification, and during that is use that recirculation of air to force a faster drawing in of air. But I want to add in a little bit of extra air, and I want to add in a little bit more than just extra air. Okay, so it's like where the wood is, I need a screen there, but not like a regular screen. So this one's going to be a little bit different and a little bit, I feel, more complicated for most people to probably think of as something that they would be super quick to do. So, all right, so that initial entrance, for your air intake and the where that funnel is for where the pipe is has to be seemingly it looks like the same size. You want the same diameter, okay? All right. But what we're going to do is we're going to make a box, like a larger kind of area around there. We want a tube and a square. So we're going to cut a square into a diamond, and we're going to force it into where the tube is. So as long as the inside diameter and the outside diameter of the square tube is such that it can do this. All right, and then we're going to take that and we're going to make a basic plate. We're going to cut a square that's the same as the same as the square tube, but we're going to instead of it being a diamond, it's going to be a square. All right. We're going to put in a couple of holes, all right, to that, but like we need to make a bunch of waves and then try and bend them a little bit for that square at the where the the edges are, and then like try and curve it in and fit it in towards that tube, and then holes, of course, at the center. But you're going to want them to be a little smaller, and we're going to have slots that go in between. So it's like, it's a good way to put this. Like, so I was like, take a star shape or an asterisk pattern, okay, and then in between the asterisk, you're going to have a little bit of holes there, and then you're going to cut in like larger holes where the other edges, the wave guides you put on the sharp corners of that square plate is. Now we're going to bend those corners, like I said, towards where the bend is for the tube, but we're going to bend them in such a way where it is bent a little bit more on one side. So you all want them to basically either clockwise or counterclockwise. Depends on what you're trying to do here. Alright, but like that allows for a given amount of that coal to kind of block up that screen but still allow for air to go through, because there's going to be that box. So this is in the tube where the wood's going into, but then there's going to be at the top and at the bottom and the sides, there's going to be air, little slots that are vertical. Okay, so like not vertical, horizontal. So it's like smaller and then wider as they go towards where the screen is. Alright, now all that manages to do, because we're going to also angle them slightly in the direction of the slightly turned parts of the tips of the square, is allow for a creation of a vortex within inside of that space. And it still allows for, if there's coal there or any ash, to be drawn off to the sides, and that's also where we can add in where the extra entrances in the rear, that regasification, and any of the extra coal chunks or larger ash part, like something that can still be burnt to get fed back in and have any leftover not burned gas somewhat be recaptured. And now the rest of that chimney part at the top can be drilled with these slots, so larger at the bottom and then smaller at the top, and you'll have it slightly more towards where that initial flame front is, so after that little funnel part, and then a little bit further up. In this instance, you're going to go probably a solid, I'd imagine, no more than 3 inches thinner and fewer. But this one just straight, okay? And then you probably want to leave it there, because that little area where you're trying to, so it's like those would just be like other funnels. So you take a ring, all right, so like another tube, and then you cut a bottom out of that tube. So or well, it's already a tube. Anyways, you just bend it. So it's like you already have a ring of that. So that cylinder, you just bend it out, and then you'd add it to where those slots are just above. So that way it sticks and stays. And you do it again to the next one. But towards the top here, this is where you'd add in just holes, okay, and then you'd put tubes and you'd bend them. So it's like those holes, you want to make sure that they're a little more, I guess, teardroppy shape. And so like you're gonna get this tube and you're gonna basically hammer it a little bit on one side, and that helps with a teardrop shape. You'll get your angle grinder and your drill, because you probably had that if you're making this, and you'll flare out the bottom or that leading edge of where the teardrop is. You'll drill some holes there, All right, and then you'll cut in some slots in between where those holes are. Okay, and as that leading edge draws in air into that tube as they're stuck in, and of course you want the another ring and the those tubes that have like that funnel be from a little bit further out to really try and force some more air into these tubes. Now, what it does is it'll take that hotter air and then try and mix it with the extra colder air, and if there's any kind of small sooty particle that can still possibly be burnt, it'll burn it at the very like near the top, basically. Um, then you'll flare that part out because at that point you're shrinking that part of the tube, but you're adding more air in as well, and so like you're making it a little bit more like a nozzle essentially. And then you want it to at the top flare out, kind of like a bell end for a rocket, or like a bell. You know what I mean? So it's like you'll start to cone that out, like a funnel. And in this instance, I would just make a couple of like little triangles, okay, and some slots in those triangles. So like triangle slots on the sides, and then slots where the triangles are. So that way I can try and slot in like a little, if I, need to cook something, I can put that there. If I want to, place a heat exchanger, so that heat to water, I can slot it over that and then make it stand such that it tries to capture for all of that hot air with a bunch of little, radiators effectively. So it's like stacks of radiators that are placed on top of each other with the right shrouds, so that way it captures all that heat that's coming off of it into all the radiators, and a little bit of extra air maybe to try and make sure it doesn't melt. That'll be good. You just want to make sure that you push air in, or not air, water at the top. In this case, it'd be like where your basin of water is, the very, very top, after it's gone through all of its heat exchange. So that way it's like a pump, so that way you don't have to actually pump it. You just take a big old thing of hot, or of water, and then you get it hot, and then you can hopefully have that as your if you're wanting a shower, you got a shower now. Or if you want a heat exchanger or just hot water that you want to save somewhere, then now you have a hot water basin effectively that you can use for a bath or any hot water needs. For me, it would turn most likely into like, well, this is up over here, where there's already water, and I would have my tent down here, if I'm camping or out in the woods or something, and then I would already have water, and so I just use that as like a heat exchanger to help draw that water. If it gets hot enough, I'd just have like an extra like little bleeder system on each one of the radiators to allow for any steam to then collect and then cool off and enjoying the rest of the water coming down. Because that'd probably do it just fine. It should be hot enough to the point where you're not going to need to worry about anything in any natural water, as it would most likely be pasteurized, or if not straight up boiled to like be clean more than enough. So long, if you save some charcoal and some sand and some other stuff, some other stuff is like you don't really need that, but like some charcoal, activated charcoal. So it's like you have charcoal, you crush it up, and then you put some sand above it, and some basic rocks that you've already boiled in water, and now you have a basic filter. So then that's clean water. You got clean water that has pressure, so you can have your hot water You have your cold water, because that can also help draw water in, because it's a water pressure difference. So it's kind of like a heat pump. You know what I mean? But it's mostly about the wicking effect. So it's like if it's above you, then if you start the process of drawing it down, it'll stay at that point. And as long as you don't open it, like the valve, it won't come out. It won't keep constantly streaming in. You know what I mean? And that's a surface tension effect, effectively, is apparently what that is. But also, it's above you, so there's water pressure, standard water pressure stuff. You know. Anyways, I was just thinking about it because it was like, well, that isn't impossible to make. With the right stainless steel, or really just steel sheets, and some correct bending and correct like thicker parts for those sheets or metal, stainless steel or any metal. It wouldn't be impossible. You don't have to totally really weld it yet. I mean, realistically, you just kind of like buy like a funnel and then you just slot this in, because like Robert Murray Smith, I was watching him after that guy, is like, well, there's high temperature silicate, so you could just use that. You know what I mean? They already have funnels, or they could make a funnel for you. Truthfully, I don't think that would be impossible, because it's like this is just a larger, and then a larger piece and another larger. So it's like this diameter and then a slightly larger diameter, and at this size, and like you buy a couple of pieces and you just get some high temperature silicate and you put it together like that. You know what I mean? Or if you don't need that, then it's just a funnel is a funnel. You know what I mean? Like it's just sheet metal that you bent and then put some silicate on it if you needed to. Like that's the cold part. But like this one over here, you wouldn't maybe do that. But of course that's just a larger like tube. Like literally, it's just a larger tube and then like a bend, like a 90-degree angle. That's all you'd be doing. With and then same thing with that. The larger would then for the funnel part, you'd have like that go into. Man, that's pretty. It's just a smaller tube that then this funnel then hooks into that 90, and so that would be like a funnel that has a holes, and so that you bend that flare out part of the funnel, the wider diameter part, that you just bend that, curve it in, and you stick something to it. That's literally all that is. So I don't know. Like I feel like it's doable, for most people. You'd have like the ability to do it, and it would work. It would, capture a good amount of those coals, burn them, and have to press them against, the holes, and then any small chunks would end up getting swirled around, and then most likely, because it's swirling, vortexing in that instance, they'd get captured along the side of the funnel, and then the lower pressure center would have like, the lighter gases of the gasification possibly that aren't maybe having been burnt, but it certainly would be hotter, and of course you're not going to capture all of it. Like you're capturing a little bit here during the first part of the bend and a little bit, along the sides, but, you could just capture only the stuff on the towards that center, and then like that swirl part, but it's like the swirl part is for the heavier, bits of coal and ash, right? So it's like, you're going to want that, and that's why the chimney then allows for you to then burn whatever's there. So like CO2, while it goes up, yes, I get it, CO2, bad, yes, I know, but you're burning wood. So if you expect it to get like not that, I don't see how. I feel like that would be facetious to expect at that point, Like, really? Like, oh, I'm burning wood and I somehow managed to come out with steam. How the hell? What is your wood made out of? Where's your how? What is that made out of? Anyways, I'm gonna move on because I wouldn't believe that in the slightest. I would never believe that. But then at the same time, it's like, well, if you get it hot enough, which this might be able to do, you might be able to decompose some steam, in your water heat air exchanger thing, then burn, hydrogen. But that seems wasteful. You know what I mean? I suppose it's to cool it at that point for boiling and decomposing steam, but that'd be like on the chimney. I don't know. Point is, it's like a way to, I suppose, allow for like a better, cleaner version of a rocket stove, because it's technically speaking doing the maximum amount of burn that you could probably get done for a rocket stove design like that. And again, there are different ways of making that plate and that larger tube in the rear to help with capture or recapture of those coals and that soot and the gas that didn't burn, as cleanly as maybe you'd probably want. And so that allows for like a little bit better, and then it's just extra air. So it's like we're starting to gather more and more air, and of course that's cooling it, right? But it's like it's a cleaner burn, and truthfully, for what it's worth, you probably wouldn't want it to get too darn hot, because if you're burning just almost pure carbon at that point, it might not survive. At that level, it's like, oh, here's some sticks, and I managed to start maybe melting my steel I bought specifically to just burn some wood. Which would be a bit dangerous, I imagine. So, anyways, but still able to have a heat exchanger and still be able to use that. Yeah, go for it, I say. Anyways, there's always some other ways to do that. I had another one which is a circular cone inwards that then goes underneath, that then burns wood as it goes in, and then sideways curves, and then creates a vortex along the top, which then also has a layer of trapped, and then creates a vortex in the center that then also has like drawing of particles and separation towards back where the wood is, as you're trying to draw that in to help heat it up, dry it, and also burn that extra gas and any of that carbon along the way as it goes through, and any coals that are there, which would be a good thing, But then of course air still does escape. It's just not in the center. It's now vortexing, and then it gets going upwards. Cones back in towards like a pinch point nozzle, that's where those extra tubes are, and I talked about that in the camper van video thing for one of my concepts back in the day. But anyways, that's where some tubes are, and then there's like a little vacuum area, side area, as it kind of tries to do like a bit of a skip from that nozzle into where like this actual capture and bell end area is, which has a nozzle and a bunch of like these different sort of overhangs that are like a double helical lens. When you look at it, it's got these curved little bits that try and bend light in towards a singular focal point. Well, with gas, if you do that, and then you have an aerospike that's also helping, and in that aerospike you also happen to have, and there's of course there needs to be stators along the sides, and those stators, which are just more, it doesn't matter, they're wings effectively, but what it means is like it allows for the expanding gases to be reburnt if there is anything from that pinch point, drawing in extra air. But drawing in that extra air, it also helps that vacuum that's there as it skips over it is also connected to a series of tubes to the pinch point, but also other places in the bell end area to help with, it being seen that it needs to go to this lower pressure zone. So it accelerates it, but it's not meant to try and capture accelerative gas. It's just meant to try and accelerate it and give it kind of like a Tesla valve skip effect, so it reduces boundary. But it also means it doesn't exchange a lot there. Instead, it's just meant to try and force more and more air in at that pinch point nozzle, and then it goes off into another ginormous funnel. Effectively, it's just a big old, another pinch point. So it's like it's accelerated, and then it does another skip, and then and a couple of versions of that as it expands. So while yes, it is getting cooled, there's the bend that captures the majority of the heat, but because heat and rising thermal, and it's a pump effectively, as accelerated air, it's already accelerating, and then there's wind that has been created as a pump of the heat. And so, like, it's supposed to go through a turbine, and then the heat, the really hot part, is supposed to go off to a heat exchanger, either for cooking or for a radiator, for a waste heat radiator. So it's like another Stirling convection, where it's like it gets hot here, it's got piezoelectric, it's got, coolant that flows through and exchanges the heat with the air around us as a radiator, and then makes electricity doing that, but also makes electricity by making air current move through thermal to blow against a turbine. But it's not meant to be very, very hot air. Instead, it's more like a heat exchanger, like another radiator. But this one, it's not meant to be super, hot, that kind of thing. It's meant to be like a regular kind of windmill. That's not, it's a high temperature gas turbine or something. It's just, you can put it anywhere kind of thing. So that kind of thing. And then if there's any other wind, it'll focus it at to another little windmill, and so like that'll help, sort of force more of a reduction of pressure, and hopefully keep air going to such a degree that even when there's not much wind, I can still get some degree of power out of that, and I still have the waste heat generator. But then there's another, like a little plate that will turn into like a hot plate skillet kind of thing. It still needs to get cooled because it'll get too hot, but it can, cook for you. But then the waste heat generator still gets some of that heat to allow for electricity generation. So it's like, there's always trade-offs. It's like, you want to cook? Well, this is an easy way to cook, and you still get some electricity, kind of thing. It's just using buoyancy, potentiation, and so on for surface area Venturi effects with Bernoulli principle sucking from the surrounding air into a lower pressure zone, and then trying to capture that as best as possible, sort of a thing. Anyways, that's not really a rocket stove though, because it's more of like this is like a vertical to then like almost like a rocket, like convection sort of style, because it creates vortices, and then I already talked about it. Anyways, point is, but it gets really hot, and so like I made it with very thermally resistant material. So a way to put that is like I made a spongiform like high heat resistant steel, which would be zirconium, some beryllium. They were like, do you want to add tungsten? It's like, I don't really want to add tungsten. Tungsten's not really worth it. But like you could if you wanted to. But it's iron and some carbon, right? And some chromium and molybdenum is what I was saying. So if I dump that after getting it to like a liquid temperature and make the right ratios, which is like there's not much in terms of those ratios outside of the iron. Anyways, it goes into like these little slots. You put like ceramic around the sides that you just use fire bricks. So it's like you can cook this in your backyard like make clay bricks, and then you bake them, with some fire, like the primitive technology guy on YouTube, and then like you have these slots, and you make sure they're sanded smooth and so on, and it got holes at the bottom. And so it's like this will draw some of the air at the top here, and a little bit of argon or nitrogen or all three. But the point is like you want it to be hot air that's going in that's fairly unreactive as the liquid metal goes in, and then it draws air through these, and since it's very hot now, you once you suck air in and then you don't allow any more air to come in, and it's of course at first a liquid, but then it'll expand in a near vacuum to a vacuum. You slide a little plate over it, and now you have a version of a vacuum that's able to slowly cool off, and then you get powder coating and a vacuum. So it's pretty easy to make an actual vacuum, like kind of room for you like. So if you have a bead blaster, like I was looking at explosions and fire, and you wanted to seal that and then put it together in such a way where you can put argon in, and you got it done. But it's like, all right, so it's like, but I can suck air out of that, and then I can make that as my vacuum powder coat, and then I'd make a small little, like millimeter thick, like really heat resistant ceramic that I'd stick to that powder coat, and then I'd heat it up using IR. Now you don't have to make a ceramic. I was like, you can just kind of just buy that, you know what I mean? But it was like, here's some carbon, here's some calcium, here's some like what else did I use? Because it's like you can just make it out of a bunch of stuff around you. Like silicon, because you have e-waste. So it's like, silicon carbide, calcium with another beryllium boron you'd probably use, and instead of zirconium, like the steel, which you have to have, like you need to have a zirconium for that steel to work. This one you wouldn't want like heavier metals, so you'd probably go with like a phosphorus, or instead of a phosphorus you'd maybe do something else like a something that's easy on hand. You know what I mean? Because you wouldn't want more carbon. You're not really looking to make like a silicon carbide thing, but it's like, man, it'd be really easy if you could just force in like the right air, like a nitrogen. Like a nitrogen would probably be fine, if you did that. Which you can probably do. I used like a basic technique of shining lasers, more or less, onto a bunch of this stuff, and then putting it in a microwave while I was doing that, and then having like this plate, this substrate that I'd use like these electrostatic charge differences and electromagnetic, so it's like, and it'd stick to it, and then cool off slowly, because I'd be turning it into a plasma that I want to deposit onto this, and then I can like slide it out. And I only need a millimeter thick, so it's like, it's fine as long as I make sure to make the right cold and static or charge field different shock. So it's like I run a bunch of current, drawing, and then I make a huge like positive charge. And so like, since it happens to have plasma there, it's like that'll stick it to it. But then they're like, oh, and then people asking me as I was talking about it, I was like, all right, well, so like if I have a hydraulic ram, and I just make like a plate of this, and I make it really hot with a whole bunch of this stuff, as long as it's, orange to like white, and it's in a base, and I can squish it, and then as it's cooling, I just need to hit it with a hammer, and make sure that it aligns its particles as it cools, and then like that'll force it to kind of stick together, until like I reheat it, and then the reheating is a different type of thing. So it's like I heat it up, I let it slowly cool off, and then I'm gonna, let it heat up again. This time I'm gonna cold shock it with argon, so I'll run argon through, and then like I'll use that hot argon that I just ran through it and reheat it up again. But this time I want it to also get a little hotter than just what that was, and then slowly bring up the pressure with that hot argon into like a 7 bar is what I would use. And then that's what I was saying earlier. And then slowly, as a standard, like just straight diagonal, linear, progression from 7 bar back to atmosphere, from its, fairly high temperature, which in this instance would be no more than about 620 C. And then you drop it back down to about like your standard, whatever temperature, atmosphere, or surrounding ambient is. And so, like, you only want it to be doing that over like a course of about an hour to 3 hours, and that'd be good enough. And that basically tempers it, because you have like the spongiform, high heat resistant steel with ceramic coating in a vacuum that you just sealed off and then forcefully combined, and it's sealed, so it's like it's a two you you know us it's in a vacuum, it has a vacuum in between it, right? And so it's like you make enough of these plates, and you bend, they'd be able to be somewhat bendable as sheets. But the point is, it's like you make a couple of these, and you only want it to be about a quarter of an inch thick. And so, like, that's why it's like they're only a millimeter. It's like a tiny little thin sheet of this shit, which is another reason why it's so bendable. Anyways, you make another vacuum in between there, and you form it at the corners, and then you have it in the center, and then you have form it at the corners, and you make sure that you vacuum that out. Alright, and then that's the sides where the wood comes in, and then you have like that in between area where you have the cone with a slight, like, little, I guess 4 like little fan blades, as they go in, and then you burn it, and then it go up into like little other area scoops. Effectively, those are more funnels. You know what I mean? Like, it's like from the sides and then next to the wood, right? That would allow for extra air in that area to be risen and sucked in, and then that burns that gas. But eventually, coal is going to go through that, and so it's like that's why it goes back down. So it'll have a bigger, wider opening ring, and then you have like little divots that then help, start like little small spinning vortexes. So it's like you'll have that with a little ring and some vortex, and you'll have a cone there, like a little, aerospike. But it's like you want, technically speaking, not an aerospike. It's like an aerospike, but they're like just elongated wings or blades, that kind of thing, that help create with the right gaps, and then eventually they're no longer necessary. It creates a constant vortex because, air, when it's hot and it has to spin over like that, likes to rise, and so like it needs to create a constant, vacuum. Anyways, as it gets more and more pressurized, all of those will eventually go towards the center, which is where the standard smaller to a larger kind of standard vortex is going to be, regardless, and then like that little capture in the center, which is where, well, let's put it this way. So it's like, as it curves in, well, it's smaller, it got larger in that center, but it's not technically capturing there, where that those heavier particles are. You know what I mean? This one's difficult because it's like you can capture on the outside, right, and like that'll be just fine, and you can have that kind of suck in with that vortex. Like you're going to combine multiple vortexes into one, as they'll still maintain a momentum, and so you'll have conservation of momentum that helps with that spin, and it increases its effect. But the problem is like as it goes and turns over, stuff can get stuck in there. They're not a perfect vortex all the time, sort of stuff. You kind of want it to like allow for particles to effectively go through superheating, but also like heating and squeezing moments, which is why it's made out of really thin kind of material, but it's very heat resistant, and so it'll bend and flex a little and kind of crush it down. So it's like that's kind of why I'm doing it. And as it forms a vortex, it'll start spreading itself out, but also sucking itself in, and so it'll create a constant sort of effect. Anyways, but so the reason why is like as it turns in, you can capture some of that initial with like a little cone and the right little separation with another funnel in that, and so like that'll help like draw it out towards that center, and then that cone, well, to us looks like it's point is that's where a lot of wind pressure has to come from. So it's like a lot of pressure here, and then that goes off into the already being sucked in hot gases, and the little skips overs until it gets into the actual funnel where the wood's being drawn in and everything. But it's a little further in, so that way it actually draws that air in. So it's like you have to have the right channels there. And so it's like it's a couple of pieces essentially that are like that, because you have like the outside and an inside vortex that has to combine at the little ring area, and then like separations along the way. And that's also another reason why I have that drawn in air where that little pinch point is, and also the bell end, so that way it really allows for a separation of a lot of those burnt combusted gases, and allows for mixing of fresh air and that stalling effects and spinning effects to be used to help create a mixing of that air and any other fuel that has not been burnt yet. And then eventually it goes to what is essentially a turning over point, like goes off into the heat exchanger area, and then it's just as that extra air has already been drawn in, and that's why we have the spinning. And so that's another vortex of where the hot goes one way, cold goes another way, and then more air is drawn in around that area too to help the effect. And so while it's still warm, in fact it'd still be quite warm, I need more air coming in and then more air again coming in to actually turn like an actual windmill. But then I took most of the heat that I really need and drew it to the point where I have a heat exchanger area that I use for with the piezoelectrics and a Stirling diaphragm and some thermoacoustic and Jules Thompson. So it goes from small to medium to large, and then in that large it gets taken into a bunch of small tubes and the right thickness and the right small to medium and then large and then small as it goes through with the fins, and then the right diaphragm and bending points. It creates a vibration which allows for heat to be more efficiently taken from the center of the tubes to the outside of the tubes, but also allows for a flexing and a kind of like a air pump to be produced with a resonance. And then there are diaphragms where there is a near vacuum and the Stirling effect that wants to draw in, and then that also helps with the air pumping. There's still a fan because it's supposed to be attached to an actual van, but it's like this is just like an extra hose attachment that's plugged up. So like then I can just draw it over to where I put this and some windmills and some solar panels over to charge the batteries, that kind of thing. Which was I felt a little easier, especially when it was like, well, I can clean up the area anyways of any dried brush and twigs or anything, and like any plastic would probably be just fine getting burnt in this because pyrolysis will definitely happen as sort of a kind of a thing. Anyways, but I wouldn't consider it like a rocket stove, I guess, at that point, because it's more of like a vortex, inducer rocket sort of Venturi Bernoulli. I don't know. It's not really technically a stove either. It's more of a thermal pump, heat exchanger thermal pump thing, so it's yeah, because it has like the funnels as it goes up, and then there's going to be windmills like the vertical, horizontal windmill design with the Darwin funnels, uh, which is I think a decent kind of way of doing that to try and draw more air in, but then also using those little vortex, uh, moments to allow for heat to come in, to like the drawn continuous vacuum sort of effect from the much hotter, much faster moving air down below, and eventually that can't be done anymore. So it's just standard air is being drawn in more and more, and just trying to potentiate the effect. But eventually you can't do it anymore. So it's like there's a fine line, and then that's it. That's where the turbine or the windmill blade has to be, kind of a thing, at that point. So that way I can try and capture a kind of sort of min-max, and this isn't going to be larger than like 8 to 12, maybe 15 feet at most, which I really doubt it would even get to 15 feet. So there's that part, but yeah. What it means is the carbon dioxide is no longer sooty. It means that I don't need to worry about clogging up anything when it exchanges. It means that while yes, it's an air pump using heat, it's a heat pump, standard convection heat pump. It's just being done in an efficient way, and there's still shrouds off to like the side to try and draw air in that are kind of solar panel, things. Because it's like, well, I mean, you'd have to have them there anyways. You know what I mean? But you don't. But like, for me, it's like, well, it's supposed to hang off the side as like a mountain if you camp at a mountaintop, or if you're so inclined, it's like, well, that's a little slope, and so air can come over there, and so it's like, well, that would be drawn to this, anyways. And so like, might as well just put some solar panels there, because they're shrouds anyway. So it's like, whatever, right? Anyways, but that's kind of what that design was. But this wouldn't be that. The rocket stove is the rocket stove. You know what I mean? So it's like the initial tube is really what I'm kind of trying to sort of change. And it's all about how you angle and drill in those holes and the sizes of those holes and these slots. So if you angle and you try and angle grind into those slots, you got to do it at an angle, so that way it like helps with that effect. If you wanted to get really really into it, you can start filing in little wave guides, and try to help the vortex effect that's being produced here. Same thing with the triangle that's in between those little bent in parts, to help with that vortex inducing sort of effect that we're really looking for. But it's of course also a screen that you're looking for to try and do that, but also the slots on the side with the little wave angles, and filed in. If you want to go really far with it, I still think it'd be worth it, because of course it's going to improve the efficiency of the vortex and the mixing of any extra air and gas that you got, and all the rest of it that goes along with that, because it'll recirculate everything, so it really efficiently burns whatever wood you got, and produces a lot less soot, and should produce more air coming through, which is good, and hopefully not in such a way that it makes it literally melt, which would be a good thing, because as I'm drawing more air in, even though I am burning that fuel, it's probably a lean mixture. You know what I mean? And so if you add in like a sliding valve, which means it's just a sliding ring for that funnel, you can kind of choke it or open it up a little bit to provide better, but of course, better air fuel mixing. But of course, you have to deal with the other problem of like it gets hotter if you do that, uh, and so you probably want to have more air than fuel. Of course, then I'm thinking about cars, and cars when they're lean they burn hotter, but then the fuel takes up and soaks up the heat, and so it's like you probably end up doing the more fuel to air, and then have it burn up in the chimney with the rest of that stuff going on there, but then of course you got more air by the time it gets in there, or hotter fuel, I suppose, so it's more willing to, once air gets in, burn much more readily and vigorously, I suppose, which would be a good thing at that point, because I mean, just because it's a funnel doesn't mean that like heat transfer isn't going to happen. You know what I mean? Like, I could probably pretty quickly in between each one of those funnels, and even onto the funnel, add like a branching out system, like kind of like a tree of maybe a thermal siphon effect of like aluminum, but it's a ring and a cylinder. I put it in water, but I'll suck out some air, and then it'll exchange it to like a regular radiator and condense from a larger tube back to a smaller, and then run back in. So long as you're in that area, of course you gain that heat. You probably want to put like a vacuum insulation around that if you can. If you can't, then you get some mud, sun dry it, bake it, on there, and that's kind of like an insulator. It's not technically a full insulator, but it's kind of like an insulator. You know what I mean? Some wigs and I'm sorry, twigs and some. There's ways to do it, but I'm gonna move off because at that point that's Adobe. You know what I mean? Like, and so like it would help to have some basically like insulated bricks at that point. But I'm gonna move off of that because it's like, well, I came up with that kind of as a way because Robert Murray Smith did this like mantle with like these dual cans, and I was thinking, well, if you got like this bigger kind of coffee can, and then like a smaller like little soup can, or like a couple smaller like little soup cans, you'd be able to then allow for a recirculation effect if you were willing to get like sheet steel, and you cut like slots in it at the top, and then rolled the sheet steel in such a way that it captured some of that exhaust coming out, and then tried to recycle it from that wider area into like a smaller diameter area at the bottom, which will draw in air, but there's a heat exchanger there of like a couple of cans or a couple of aluminum sheets that you just sort of bent and then bent next to each other and get the high temperature silicate, and then like you allow for that lower pressure, but that's what actually goes into your home. So it's like the rest of it's while it sits inside, it draws air from the outside and then circles it out, and then you'd have like a long sheet steel kind of chimney, so that way you don't have that come into your home, and then also it doesn't burn your roof or anything, which would be, I think, a good thing, especially since you could also add in like that thermosiphon heat exchanger. As it gets condensed, it can go off into that side, but also into the funnels. Now, the reason why I was talking about the funnels at the top is it'll draw in already combusted air, and you can have some of it go around the can and into that heat exchanger mantle area that keeps it a little warmer, but also some of it going to the fresh air coming in, and some of that fresh air coming in to go off into that area too. So that way, while yes, I'm not getting technically more air, a little bit more, I'm recirculating that heat, trying to make it more efficient. I don't want to burn larger and larger amounts of fuel. I want it to actually maintain kind of a steady burn, and I can always slide open something at the bottom and stick some more fuel in. You know what I mean? But what it also means is that that soot and everything else can try and be lessened by that recirculation of combustible gases, and since it's not got enough air to really increase the burn rate, I'm still able to burn a adequate amount slowly over time that's more reasonable, but it's more efficient, exchanging that heat to the air around you without hopefully putting a bunch of carbon dioxide into your home. You just have to have an open window, unfortunately, and a coffee can and some other cans. It's like, I don't know. You kind of probably need like a fire brick underneath so that way it doesn't burn your windowsill or anything. I don't know. I feel like you could get away with it. You know what I mean? Like, I feel like you could get away with it. It's just also that chimney, you'd probably want to mix some other air so that way it really reduces that soot and those particles, in terms of like the amount per parts per million, because you can't capture all of it. You know what I mean? Like, you can try and capture some of that over a distance and try and like suck that back in from that chimney, I suppose. It's going to stick to the side of that chimney, like, no matter what. So it's like, eh. And then the rocket stove is another version of that. It's like, well, I suppose you could stick it on your windowsill, and from that chimney you could still have that heat exchanger, sort of a thing, right? And then that can help heat your home. You got plastics, as long as they're pyrolysis and good at burning types of plastics that are not super carcinogenic, and you have the proper recirculation to really make sure that you burn appropriately everything, because at that point I'd probably put an O2 sensor or something like that at the top, or particle sensor, or that kind of thing, or just a basic air filter, just to make sure that because I can burn that, you know what I mean, like, I can recapture that at the top, as long as it's cold enough, I can reburn that. It doesn't need to be if it's cloth and oil, like a K&N filter, as long as it's cold enough, then I can burn that. You know what I mean? And so, like, that'll be fine. Or like a turtle filter, that'll still work, right? I'll have to get a couple of filters, but like, that'll work, right? So, but I felt like that would be a good way to have a low-cost solution to being able to have like a really efficient burn that can have a very high heat transfer, so long as you do it right. Because like, even at that little tube area, you can still definitely heat exchange there. Like, it's still gonna get warm. Same thing with the chimney. Just because the gases are something you're trying to capture doesn't mean like the actual area where all of that combustion is really kind of happening, you can't exchange some of that heat. In fact, that would probably be still a decent idea, just to make sure that you don't melt the thing, you know what I mean? So it's like, might as well try, I suppose. Anyways, have a good one. Bye. Try out the design. I'd love to know. Like and subscribe, please. Here you go. Please. And bye.